Grinding wheel specifications explained. Basically what I'm going to do is I'm going to go through the grinding wheel specifications and I'm going to explain them using household products. Okay, before we get started, please like and subscribe. It's free and it'll help me out. Okay, let's get started right now. On your standard markings for a grinding wheel, there's 5 things that you need to know. Okay, there's usually a manufacturer symbol here and a manufacturer something here. But you want to see the 5 in a row that are the most important. So our abrasive type, our grain size, our grade, our structure, and our bond. Let's talk about the first one here, which is our abrasive type. What does it matter? If 70% or 75% of all abrasives are made of aluminum oxide, what do we care about these other things? What is the actual abrasive and what does it have to have? It has to have certain characteristics. Well, the abrasive has to be strong enough so when it swirls around the wheel, it makes contact with the piece of metal that you're going to grind or object that you're going to grind. It needs to be harder than the actual object itself. It also has to be able to withstand the impact of swinging around. It's actually, as it goes around, it actually does hit your workpiece as it goes around each time. So there's some impact in there as well. It also has to be able to withstand that amount of heat that's generated from the cut. Okay, so let's say aluminum oxide is awesome for a piece of high-speed steel. Someone says to you, hey, take your lathe bit and go sharpen, and you come up with this guy here, and you say, okay, I'm going to go sharpen this. Well, if you choose an aluminum oxide bit, this is carbide. Carbide is much harder than aluminum oxide. So what's going to happen is this piece will just groove the wheel without actually sharpening this bit. So what you'd have to do then is pick a diamond or a silicone carbide wheel, which is, a lot of guys call them the green wheels. Okay, next let's talk about the grain size. Well, we have a lot of different grain sizes, and there's a couple more I just didn't add on to here. Most of the time what we're going to be running with here is probably more or less in the medium. Now, the grain size is actually, let's take these rocks here. So let's say that that is in the coarse. I'll put these guys here in the medium. Oh. And we'll say that these guys are the fine or ultra fine. Why does it matter? Oops. Why does it matter? Because this abrasive will take a larger chip than this abrasive will. So the rougher finish that you want, you would want a larger grain size, and the smoother finish that you would want a smoother grain size. So, well, what's the difference between these? Is you'll get a better finish, or sorry, you'll get a rougher finish with these guys, and you'll get a better finish with these guys. You can take more material off with these than you can with these. So as the grain size gets smaller, the less amount of material you can take off. As the grain size gets larger, the more material you can take off. Okay, we're going to talk about grade now. So J is in the medium grade. You say, well, what does that mean? That's the actual strength of bond. So our grain or our grit is actually glued together to another piece of grit. Okay? So the strength of that glue is what our bond strength is. So we'll say this is soft. We'll say this guy's medium. And we'll say this type of stuff here is in the hard. Okay? And you say, well, Ray, I really don't care. What does it matter? It matters a lot, to be honest with you. And where it comes into play is something called friable or friability, which is the ability as this grain here swings around and it hits a piece of metal, it gets dull after a while. It gets a flat on it, right? So what we want this piece of grit to do is to be able to release itself. Okay, so if you have a really weak bond, right, which you'd want for harder material, like harder steel, so because every time it comes around, it'll dull itself quickly, you want this material, you want this grit to be able to release on hard material. So a softer bond would be easier to have it release, and then there'll be a sharper or a new grit underneath, which will take its place. Now on a hard bond here, let's say you're doing a very tiny area and you're sharpening, let's say a knife or an edge or a blade, or a very small area. For something like this, you want a hard bond. But for most of the stuff that you're grinding, you want a medium bond. Does that make sense? I hope so. Structure. Okay, so our structure number here depends on where we are. 1 would be dense and 15 would be open. So let's take a look at what that actually looks like. So a dense wheel, where the grains are more compact with each other, is better for finishing applications and fine grinding and grinding hard material. A more open wheel allows chips to be released and better coolant access if you're using a through wheel coolant system. You just need to pick the one that's right for the particular job that you're doing. Okay, bond type. Bond type. About 70% or 75% of bond types are vitrified. Rubber would be used for something for polishing. So depending on what you're doing will depend on the type of bond that you actually want to use. Some of these advantages are you can use coolant on them. Some of them you can't use coolant on. Okay, we are going to talk about grinding wheel identification. We're going to start with a pedestal grinder wheel, then we're going to talk about a surface grinding wheel, then we're going to talk about a cylindrical grinding wheel. So let's take a look here. This is a box, a brand new one. The identification on a pedestal grinding wheel, they kind of limit it or make it easier for you to identify. So right here it tells you that it's a bench pedestal grinding wheel. It gives you your sizes on the outside, tells you that it's an aluminum oxide, it's a medium, and it also tells you the manufacturing date. Let's see what the wheel actually tells us. It's 17 years old. Not worried about the wheel itself. As long as it's inside a package, it's basically good forever. So let's take a look here. What do we have? It's telling us the most important part here is our maximum RPM. Do not ever exceed the maximum RPM. And it tells us our size here. So if we look at the 6, that is the outside diameter, 6 inches. Then it tells us 3/4. So that's our thickness of our wheel. Then the last part tells us our hub size. So if we take all these pieces of plastic out, that's going to be 1 inch. Now there's not a whole lot more. Hang on, I gotta blow this up. Let's move this out of the way. There we go, that's a little bit easier to see. So it's telling us that we have a 60 to 80 grit wheel. It's a medium, and that it's a bench pedestal wheel. You're not going to get a lot more, and if you can't read this here, they got a nice little photo there telling you what it is. Okay, so let's take a look at a surface grinding wheel. Again, our most important is our speed. We do not ever want to exceed our speed. We take a look here. The 38 doesn't really mean anything. What we want to see here is our A. And what does our A represent? A represents our abrasive, which is an aluminum oxide. So then we want to go to the next one, 46. What does our 46 represent? It represents our grain size. Then our next one here, our grade, is I. Then we have an 8, which is our grain structure, which is how closed, or sorry, how dense or how open our wheel is. And then we have a V, which represents our bond, which is our glue, which is vitrified. Then we have an outside diameter of 7 inches. We have a wheel thickness of 1/4, and then we have a hub diameter, our internal hub, of 1.25 inches. It's aluminum oxide. A represents aluminum oxide. So now we take a look at the 60. 60 is our grain size. Then we take a look at our L. So it's a medium. Next up is our 5, which is a dense wheel. Then our V is vitrified bond. Okay, now let's take a look. 14. Our 14 here represents the actual diameter of the wheel. The 1 inch means that the wheel has a thickness of 1 inch. Our 5 means our inside diameter is 5 inches. Okay, I want to do a little demo. What I have here is a nice aluminum oxide wheel, and I have a real diamond wheel. Okay, so this diamond wheel will cut through carbide like a knife through butter. The aluminum oxide wheel basically will not touch carbide at all. So I just wanted to show you the difference. Now, aluminum oxide works great for high-speed steel. Diamond wheel will cut, but unfortunately this material is soft and it clogs the diamond wheel almost instantaneously. So you do not want to use soft metal on a diamond wheel. Okay, now we talked about the importance of RPM. Whenever you see a grinder, there's always RPM listed. So if you're mounting a wheel, check your RPM to make sure that the RPM of the wheel is faster than the RPM of the grinder, okay? Now I did all the talking before I turned it on, so you might have a hard time. So I'm going to show you an example of using carbide on a aluminum oxide wheel. Then I'm going to come over here and I'm going to sharpen it a little bit, just take a small amount off with the diamond wheel. Now I'm going to put a small groove in the wheel. It did nothing. Nothing. Oopsie. Nope. See how I put a radius on? You have to choose the right wheel for the right job, and the right wheel for the right material. Well, I hope that you enjoyed the video. Sorry about the last shot. I didn't quite focus in on the cutter, but trust me, there is a nice radius on there. If you want to see other great videos, please check out my YouTube channel, Shop and Math. Also, if you have any comments, please leave them in the comment section below. I want to hear back. And please don't forget to like and subscribe. It's free, and it'll help me out. Thanks for watching the video, and have a great night.